Good morning to everyone. Today we are going to learn about qualitative test for carbonate, sulfate and nitrate. That means qualitative test for several ions, anions especially. In last class we have learned some other ions, that means especially for halides, chloride, bromide and iodide. But today we are going to learn about the qualitative test for carbonate, sulfate and nitrate. Here you can see the observations, what we will observe from confirmatory test of the carbonate, sulfate and nitrate. Here you can see, if we do some experiment or if we do some test, then we have put some salt and then we are getting some gas or effervescence, and then this gas is passed through some calcium oxide or lime water. Then this lime water will turn into turbid. That means if you have the clear solution of calcium oxide, then it will become some dark or it will be turbid. So if you find these types of observation, then you can confirm the presence of carbonate. However, in case of sulfate, we will observe some white precipitate. Here you can see the precipitation is in the bottom, so even whole. So that is the white precipitation of some sulfate with the barium sulfate. So for carbon nitrate we will get some ring. Here you can see there is little bit clear solution, here also little bit clear or little bit darker. However, in between two layers we are getting some ring, that is known as ring test. So we will learn how we can form the ring or how we can generate the white precipitate of different sulfate with barium, and then we will learn the precipitation or gas, effervescence or gas from carbonate. So let's start what we can do or what types of experiment we will perform to confirm the presence of carbonate, sulfate and nitrate. Qualitative test for carbonate. We are going to start with this carbonate test with dilute hydrochloric acid. So if we take some salt and then add some dilute hydrochloric acid to a carbonated salt. Carbonated salt, it can be sodium carbonate, potassium carbonate or any other carbonate. So I am showing you just only as a carbonate. That doesn't mean you need to have any precise or a specific salt. Just you can have any carbonate salt. So add some salt or take some carbonated salt in a test tube. Add few drops of dilute hydrochloric acid. So if you take carbonate salt and dilute hydrochloric acid, the salt you don't need to dissolve into water. Just take a solid salt or just it can be crystal or it can be powder or whatever. So just take the solid salt and add dilute hydrochloric acid. So what will happen here? If you add some hydrochloric acid to a carbonate salt, then what will happen? The carbonate will react with hydrogen of or acid. So hydrochloric acid gives H+. So what will happen? These types of reaction you can get. Carbonate reacts with acid to form carbon dioxide and water. So you will observe some effervescence or some gas in the test tube. So how you can confirm this gas is carbon dioxide? So reaction says we should observe carbon dioxide, but by observing you cannot confirm that this gas is carbon dioxide. That can be water vapor or oxygen or any other thing. So how you can confirm that gas is carbon dioxide? That means we have added hydrochloric acid or any other acid. So just we have added acid to a unknown salt, that can be carbonate salt or any other salt. So if you observe some gas, either this gas is carbon dioxide or any other gases. So how you can confirm? To confirm it, you need to have some further test. What is the further test? As the gas is evolving or effervescence you are getting, you need to confirm that this gas is carbon dioxide, so that you can make sure that this salt or our sample contains carbonate. In that case, you need to pass this carbon dioxide or the gas what we are observing, or effervescence what we are observing in the test tube, you need to pass this gas through a clear lime water. Clear lime water, what is this? Clear, sorry, here I have made one mistake. This 2 plus should be in the top. Okay. So lime water you need to prepare instantly, because if this is not prepared instantly, then what is the problem? The lime water can be turbid itself, because if in our environment we have lot of carbon dioxide, so if you have prepared the lime water maybe few days before, in that case the environmental carbon dioxide can contact with the lime water and it can be turbid. So if you pass more carbon dioxide, in that case you cannot get the turbidity, or you cannot observe the turbid change, or whatever the change we should observe. So you need to prepare a lime water solution instantly. How you can prepare the lime water solution? In that case you can add some calcium oxide into a test tube or into a beaker. Calcium oxide, just this is a lime, this is lime, so add some calcium oxide and then filter it, because calcium oxide, all of the calcium oxide may not be dissolved, or it can be little bit dark, whatever. So to get the clear solution, you need to filter out the residue or whatever the sample may have inside. So just to get the clear solution, you need to filter using a filter paper. So first dissolve some calcium oxide or lime into a distilled water and then filter it. That will give you the freshly prepared calcium oxide or lime water solution. Okay, then take the carbon dioxide, whatever the gas is produced, we don't know this is a carbon dioxide or whatever. So pass the gas what we are observing through the clear solution of the lime water. Then if you observe no change, that means your solution do not contain, or the gas is not carbon dioxide. But if you observe that the lime water changed some color or it became turbid, in that case you can confirm the gas is carbon dioxide and your sample contains carbonate. So how you can pass the carbon dioxide through the calcium oxide or lime water solution? In that case you have to make some way, or we will provide you that sometime bent tube or U tube, so that you can take the gas through the tube and then you can pass through the lime water. In that case today I will show you some good video that they have made their YouTube little bit complicated, however it is very good. If we can provide these types of cell, that will be very good for you. So let's see the video what we can have, or how we can pass the carbon dioxide gas, or how we will observe. First let's see taking the carbonate salt. This is taking carbonate salt. So this is the salt, carbonate salt, and we are taking into a test tube using a spatula. So most of the case the carbonate salts are white, or more normally we should say this is colorless, however not colorless exactly, because white is a combination of 7 different colors, so we will say this is white. Anyway, so test for carbonate ions, first taking the salt, carbonate salt into a test tube, solid salt, okay, then adding dilute hydrochloric acid, or okay, now observe what is going on. Here you can see effervescence. So here getting the effervescence, but already finished. So you cannot test this way. So that is difficulty. So if you add carbonate salt and add the acid, immediately it will react. So you have observed that some gases or some effervescence are evolved. However, that is finished within a short time. So you cannot pass this gas through anywhere. In that case, what you have to do? In that case, let's see, you have to take little bit more salt, and also you need to make the you need to take more salt, and you need to prepare a system before before addition of the gases. So before addition of the acid to the sample. So you need to prepare, or you need to be ready before the addition of acid into the carbonate salt. So how we can prepare this? Let's see. Okay, this is the same thing what we have shown. So this gives clear solution. It has nothing to do, because just changing carbonate to carbon dioxide and water. So there is no precipitation, so it is giving clear solution. Okay. Then taking another test tube. Okay, this is the U tube. This is the U tube already attached with a test tube, and this is the bend part, and in this part you will add calcium oxide or lime water solution, clear lime water solution, so that when you add the acid, and you need to stop this test tube, the mouth of the test tube, by your finger immediately just after addition of or you can use a stopcock or cork or any other thing, any other way, so that immediately you can stop the mouth of the test tube, so that no gas or no effervescence can escape in this way. So by this instrument, this is even easier, so you can have the gas easily through the calcium oxide or lime water by this way. So first you have to take the lime water, clear lime water, in this bend portion. So you have to add through this way, and take the lime water through this way, and then take salt into the test tube, and then you have to take HCl or sulfuric acid, that means some acid, into the test tube, and immediately just after addition of the acid into the test tube, you have to stop the mouth of the test tube, so that any gas what generated inside, it will be immediately pass through this hole, this tube, so that we can get the carbon dioxide gas pass through this tube. So you can have the change whatever we are expecting. Inside we have lime water, so when carbon dioxide passes through the lime water, that will turn into turbid due to formation of calcium carbonate. So inside we have calcium oxide, so when you pass carbon dioxide, that will turn into calcium oxide reacting with carbon dioxide, that will give you calcium carbonate, which is insoluble, so you will get some turbid color inside the lime water. So let's see, but today I am showing you good instrument, but the observation is not very good here. So you may not observe very good change or turbid color here. However, that is possible, but I think they didn't add sufficient amount of acid, or the time is not enough, or they have some difficulties. However, the observation, that means the turbid color, maybe in this video you cannot observe the turbid color. However, that is possible. I did myself and I could observe. So but this instrument is even better. What we have used is just a bent tube here. So just like as a over U tube, and that is inverted U tube, and we have attached the tube here in the mouth of the test tube, and then put the lime water inside another test tube. That is also fine, but I think this one is even better. So if you use these types of instrument, you can get better observation compared to what we have used. Anyway, so let's see. So this is the instrument what we are going to use, or what they are going to use, and you have to take the sample in the left side, that means in the test tube. You are taking that sample. I think it should take little bit more, because if yes, he's taking little bit more sample. Okay, then add lime water, freshly prepared lime water. Here they have filtered the lime water to get the clear solution. Here taking the lime water in the small tube. Here you can see in this tube they are taking the lime water. Now we can see this is the clear solution of lime water, and here is the salt. Then he is going to add acid to the test tube, that means the sample, inside the sample. So here you can see the effervescence. So immediately he should stop. Immediately he should use his thumb to stop. Now you can see the gas is passing through. Here you can see the bubbles are coming out. So that means some gas is coming through the calcium oxide or lime water. However, you need to pass a certain amount of effervescence or gas through the lime water to make it turbid. Otherwise, you will not get the change in color. Therefore, he has taken certain time to stop the mouth of the test tube, so that he is not getting very turbid color. However, if we perform these types of test, we will immediately stop the stop the mouth of the test tube, so that we can pass most of the effervescence or most of the gases through the lime water. Even in this case, we can add some more acid or more salt in the test tube, so that we can perform the test again. So that just we need to pass a specific amount or certain amount of carbon dioxide through the lime water to make it turbid. And that is the confirmatory test for carbonate. And we have several other tests. Let's see, we have other tests. Okay, this is already done. So test with barium chloride or calcium chloride solution. If you take some salt, a pinch of salt, dissolve into distilled water. Previously we have taken the solid water, a solid sample. We don't need to dissolve. Just take a pinch of carbonated salt, dissolve into water, add few drops of barium chloride or calcium chloride solution. So we are doing some test or experiment, or we are adding some chemicals. What happens? Calcium carbonate or any carbonate, whatever the carbonate salt we have, this is the carbonate. So carbonate salt reacting with barium 2+ or calcium 2+. In that case, you will observe a white precipitate. carbonate reacting with barium or carbonate reacting with calcium. So we are getting barium carbonate or calcium carbonate. That means if you add barium chloride, you will get barium carbonate, or if you add calcium chloride, you will get calcium carbonate. But both of them have the color white and they are insoluble, therefore you will get white precipitate in the solution. So if you observe the white precipitate of barium carbonate or calcium carbonate after addition of barium chloride or calcium chloride, then you can confirm the presence of carbonate in your sample. So that is very simple. So if you have performed these types of tests, then you can confirm the presence of carbonate in your sample. Then we have another test with silver nitrate. Silver nitrate, in the last class I have mentioned that we need to keep the silver nitrate in a dark bottle so that it do not come into contact with the light. So if it come into the contact with light, then it is destroyed and it is reduced, or you change some oxidation state so that we do not have the pure silver nitrate. In that case you may not get the very good observation. So how we can perform the test with silver nitrate for the carbonate salt? In that case, take a small amount of carbonated salt, dissolve into water. Similar thing what we have performed for barium chloride or calcium chloride. Everything, just if you need to dissolve some salt, just take a salt into a test tube and then dissolve into distilled water, or take some distilled water into a test tube and then shake very well, and then you will get a clear solution. But if you do not get the clear solution, you can heat a little bit, or you can add warm water. In that case you should get the dissolved solution or clear solution. Even if you do not get the clear solution, in that case you can get, or you can do the filtration to get the clear solution. So you should have certain amount of salt ion in the dissolved state or in your solution. You don't need to have dissolved 100%. Just if the salt is soluble, then you can have, but if you do not have, that is also fine. Just dissolve some of the part of the salt into a test tube, and then if you do not have a clear solution, you can just filter it out and then you will get the clear solution. So after that you can perform the rest of the test using the clear solution. Why you are taking the clear solution? Because we may need to have some observation, that is sometime dark or colorful or different color or some white precipitate. So if our solution is not colorless or clear, in that case we will get some false observation. So always we need to make some solution which is clear or transparent so that we can have our observation. Or sometime we may have some colorful solution, but it should be transparent, that means clear solution, no residue or no precipitate in the solution. If you take some copper sulfate or iron sulfate, in that case you can have the solution some color, but that doesn't matter. You need to have the clear solution, no precipitate in the sample. So if there is any precipitate, you should filter it out before performing the test. Okay, so if you take some sample or carbonated salt and dissolve into water, add few drops of silver nitrate solution, then what happens? Carbonate reacts with silver ion to give a white precipitation of silver carbonate. So carbonate reacts with silver ion to give a white precipitation of silver carbonate. So if you observe the white precipitation of silver carbonate after addition of silver nitrate into your sample, in that case you can also confirm the presence of carbonate in your sample. That is also similar like as barium chloride or calcium chloride. We are getting white precipitation. So you may be confused if we observe two different white precipitate. Silver carbonate we are getting white precipitate, you are getting barium sulfate or sorry barium carbonate, that is also white precipitate. Then how you can distinguish? Just you need to remember what sample you have added. Silver nitrate, that will give you the silver carbonate, but if you add barium chloride, in that case you will get barium carbonate, or calcium chloride, that will give you calcium carbonate. So there is no way to get confused what sample or what precipitate you are getting. So just make sure what sample, sorry, what solvent or what the reactant you are adding to your sample to get the precipitation. Okay, now we will move for the test for sulfate. That is also very similar what we have performed in case of calcium. We have added calcium chloride or barium chloride. That means we are now taking the sulfate salt and we will dissolve into some test solvent, that should be water or something else. Take a small amount of sulfate salt in a test tube, dissolve into water, add few drops of barium chloride solution. So in case of carbonate we have mentioned that we can add barium chloride or calcium chloride. So in this test for sulfate we can add barium chloride. So first you have to take the sulfate salt and dissolve into water, then add few drops of barium chloride solution. What will happen? You have the sulfate salt and you have added barium chloride in your mixture or OS, that means original solution. You have made the original solution by dissolving the salt into distilled water, that is known as OS or original solution. So you have prepared your original solution, that means in your original solution you have sulfate salt and then you have added barium chloride. So the barium chloride reacting with the sulfate to get a white precipitate of barium sulfate, and this chlorine will give you some ion. Here we are getting the ion, so you should have some other salt, whatever. If you have some sulfuric acid, sodium sulfate or potassium sulfate, in that case you can have the sodium chloride or potassium chloride or whatever the salt you had in the sulfate salt. So based on that salt you will get the salt here. So our main target is to get the precipitation of sulfate with the barium. So if you add barium chloride into your sulfate salt, then you are getting barium sulfate precipitation, white precipitation. That confirms another thing, that confirms the presence of sulfate in your sample. However, we can further investigate little bit that white precipitate of barium sulfate, which is insoluble in warm dilute hydrochloric acid or nitric acid. That means if you add little bit warm hydrochloric acid or nitric acid, that should be dilute but not concentrated. Dilute means the number of ions of hydrochloric acid is little bit less. Therefore, if you have the dilute hydrochloric acid or dilute nitric acid into the precipitation, white precipitation of barium sulfate, in that case it will not dissolve, which is insoluble in warm dilute hydrochloric acid or dilute nitric acid, but moderately soluble in boiling concentrated hydrochloric acid. That means if you add highly concentrated hydrochloric acid and if you heat up, that means hot and concentrated, that means the reactivity of hydrochloric acid, if it is dilute, then it has very less number of ions, so the reactivity is too less and you are increasing the temperature. That was warm and that is boiling. That means this is very high temperature and this is also the number of ions of hydrochloric acid is very high. So the reactivity of hydrochloric acid is very high in case of concentrated. So the number of ions is very high. So it can react with barium sulfate to form some other soluble products. So the barium sulfate there in that case is no more, so it dissolves into the solvent, into the solution, so it gives little bit clear solution. That means it dissolves into boiling and concentrated hydrochloric acid. Okay, let's see the test. This is barium chloride. It has some residue in the bottom. However, you should take some the solvent, or sorry, barium chloride from the top. You should not take from the bottom, because barium chloride is not completely soluble into water. So if you filter the solution, that is very good, but if you do not filter, then you should take the sample or barium chloride from the above portion, not from the bottom. So first, this is your salt, magnesium sulfate or calcium sulfate or whatever, any salt, sulfate salt. So take some sulfate salt into a test tube. This is our empty test tube. So take the salt into a test tube and then dissolve into distilled water. That means add some water to the salt and then shake it very well, and then add barium chloride to the test tube. That means the solution or original solution, that will give you the original solution when the magnesium sulfate is dissolved into water. That is known as OS or original solution. So let's see this magnesium sulfate, this salt is taken into test tube. Here you can see this is taken into test tube. Okay, and then dissolve into water, add some distilled water. Yes, now taking the distilled water. Okay, enough. And then you need to take the test tube and then shake it very well, shake it to dissolve it. So it is almost clear, but I should shake little bit more, and also I should not take the sample. Magnesium sulfate, they are taken little bit more, so just take a little bit amount of some magnesium sulfate. So because you don't need to take huge amount of magnesium sulfate here, because we will observe a very clear precipitation. We will get a white precipitation here, so we don't need to have too much salt. Just we need to have a small amount of salt so that we can dissolve into water. So you should take very small amount of salt and dissolve into the water to give you clear solution or transparent solution, so that you are not getting confused if the precipitation is here or not. If you have the colorful or white precipitation in the solution before addition of barium chloride, that is not good. So you should take a small amount of salt and then dissolve into distilled water very well, so that there is no precipitation. Okay, this, let's consider this is clear solution. Then addition of barium chloride, taking the barium chloride solution, let's move. Okay, the taking the barium chloride solution and then just look at just with single drop. When it has added only single drop, immediately the precipitation started to appear. So previously it was some little bit turbid, not white precipitation. So after addition of single drop, here only 2 drops have been added. So 2 drops of barium chloride is enough, or 1 drop is also enough. So you can have the change what the precipitation is here. So if you have the white precipitation, and you can confirm the presence of sulfate in your sample. So for any sulfate test confirmation, just dissolve into water and then add couple of drops of barium chloride clear solution, and then you will observe a white precipitation like this. So if you have the observation like this, white precipitation of barium sulfate after addition of barium chloride, then you can confirm the presence of sulfate in your sample. Now we have some other test to confirm the sulfate, but I will not show you the video. Test with lead acetate solution. We can have several tests. Test with lead acetate solution, that is also similar, just different chemical. Previously we have added barium chloride, now we will add lead acetate solution. So take a small amount of sulfated salt, dissolve into distilled water. Similar thing, just you need to remember the way of preparing the OS of an original solution. Just take a salt, dissolve into water, make a clear solution. If this is not clear, just filter it, that will give you clear solution. So that is your original solution. So always, most of the case, to test for the anions you need to prepare a OS or original solution. So take your original solution and then add few drops of lead acetate. So sulfate salt and original lead acetate will react each other to have a white precipitate. One very strange thing or surprising thing, that most of the case what test we are discussing here, we are observing most of the case the white precipitate. So lead sulfate, lead and then barium chloride, barium sulfate or barium carbonate, most of the case we are observing the white precipitate. So if you add certain chemical, lead acetate, barium chloride or silver nitrate, these types of chemicals, most of the case we are getting white precipitate. So this is giving the reaction when you are adding lead acetate with the original solution of sulfate, then you will observe a white precipitate. So if you observe the white precipitate, that can give you the confirmation of presence of sulfate in your sample. However, you can perform another observation. PPT is soluble in hot concentrated sulfuric acid. That means if you add some concentrated sulfuric acid into the precipitation, that means this is the white precipitation, and if you add hot concentrated sulfuric acid, this is dangerous. I should not recommend you to do this, because hot concentrated sulfuric acid, this is quite vigorous, this is very dangerous. So hot concentrated sulfuric acid, that means this is even dangerous. So I should not recommend this. I have collected this from the book, however I should not recommend this. So just if you have the observation, that means the white precipitation of lead sulfate, then you can confirm the presence of sulfate in your sample. That is done. So I will not recommend you to, maybe if we have ability to perform the test, I can do it by myself, because I would say I have little bit more experience, and maybe I can use some precaution, or I can use gloves or any other precautions, use apron, everything. So I can do the test, but I would not recommend you to perform these types of test with hot concentrated sulfuric acid. Anyway, so if you have the observation after addition of lead acetate into a sulfate salt, then you can confirm the presence of sulfate in your sample. We have another test, silver nitrate, similar thing. Take the original solution and then add few drops of silver nitrate, like as what we have done in the previous samples. So take the original solution and add few drops of silver nitrate, and if you observe the silver sulfate or white precipitate of silver, white crystalline precipitate of silver sulfate, confirm the presence of sulfate 2- ions or sulfate ions in your sample. Very simple. Now we will go for test for nitrate. That is very interesting. So and you can perform the test, and you need to be careful to perform the test little bit more, because if you are not careful, in that case you will never be able to form the ring. how you can perform the test? First, you have to prepare the original solution. Take a small test with no, not this one. Later, in next test, I will show you the ring test. But this is another test. Test with concentrated sulfuric acid. Take a small amount of nitrated salt, that is solid. So solid salt, take a small amount of nitrated salt, add few drops of concentrated sulfuric acid, and then what happens? The nitrate salt reacting with sulfuric acid. Nitrate salt reacting with sulfuric acid forms nitrogen dioxide and also some oxygen gas. So nitrogen dioxide, you will observe a reddish brown vapor. Reddish brown vapor in the test tube. You will observe some reddish brown vapor of nitrogen dioxide, and you will get oxygen gas. So reddish brown vapor of nitrogen dioxide you can observe, and then an pungent acid vapor of nitric acid which fumes in the air. That means nitric acid, sulfuric acid will react with nitrate to form some nitric acid. That means this nitrate with water. This nitrate with water will form some nitric acid in some after some time. So you will observe some fumes of nitric acid, pungent acid vapor. So you will observe the reddish brown vapor of nitrogen dioxide. So if you observe these types of test, you can assume the presence of nitrate in your sample. So that is also you need to be careful when you are adding concentrated sulfuric acid. Always be careful. Concentrated sulfuric acid is little bit, not little bit, is quite dangerous. So always be careful when you are adding concentrated sulfuric acid. Never use mouth or pipetting by mouth. Always use dropper or pipette filler to take the sulfuric acid, concentrated sulfuric acid, or any acid. Most of the acid are dangerous, so always try to follow the process. So when you are collecting the sulfuric acid, use the dropper or any other way that it is not coming contact in your hand or in your body. Now we will perform the ring test. Ring test, that means it will look like a ring. Already I have shown in the first slide that we will observe some ring, but how we will observe the ring and what are the precautions to form the ring, and also you need to follow some technique so that you can form the ring. Otherwise, if many times if you test the nitrate, most of the time you will not observe the ring. That is due to the either chemicals. Most of the time the chemicals may not have any difficulties because you are taking the solid salt and then you will add sulfuric acid. So that is not big issue. However, during the addition of sulfuric acid, if your test tube is shaked at then you can mix up the solvent or the sulfuric acid, or the ring will be dissolved. So you cannot observe the ring. However, take a small amount of nitrate salt. That is our sample. So take a small amount of nitrate salt, dissolve in distilled water. That means preparation of original solution. Take equal amount of freshly prepared iron sulfate. That is another precaution. Freshly prepared iron sulfate solution. What does it mean? You have to prepare the iron sulfate solution immediately or just before your experiment. Otherwise, if you have the iron sulfate, this is iron 2 sulfate. If you take the iron 2 sulfate or if you prepare the iron 2 sulfate solution long time before, automatically the iron 2 sulfate will convert into iron 3 sulfate. Therefore, you will not have these types of test, because to perform this ring test you need to have the iron 2 plus in your sample. So if you use the iron sulfate, iron 2 sulfate freshly prepared, then you can have the confirmation, or you can have the ring test. Otherwise, if you take ferric sulfate, that means you are considering this is ferrous sulfate or iron 2 sulfate, but you have prepared the sample or iron sulfate solution quite a long time before. Iron 2 immediately converts into iron 3 sulfate by the oxidation of air or oxygen. So if you prepare the iron 2 sulfate long time before, discard it, just do not use. Then you need to use the iron 2 sulfate. Make sure that this is iron 2 sulfate. How you can make sure? You need to prepare immediately from the salt or iron sulfate salt, and then add water into the iron sulfate. So first prepare your stock solution or original solution, then add equal amount. That means if you have 1 milliliter of original solution, then add around 1 milliliter of iron 2 sulfate solution. So then add more, then add about 2 milliliter of concentrated sulfuric acid. Previously you had 2 milliliter of solution, 1 milliliter of this sample solution, and then around 1 milliliter of iron sulfate solution, and then add about 2 milliliter of concentrated sulfuric acid solution. 2 milliliter concentrated sulfuric acid, and this is the most precaution. How you have to add the sulfuric acid? You have to add the sulfuric acid very slowly through the side of the test tube. Just you need to take the test tube, bend and like this way, hold the test tube like this way, and then add the sulfuric acid alongside the side of the test tube. But do not take the test tube like this way. Take the test tube like this way, and then add the concentrated sulfuric acid around 2 milliliter. 1 milliliter also fine, but 2 milliliter will give you better evidence. So add 2 milliliter of concentrated sulfuric acid dropwise from the side of the test tube. When your addition is over, just slowly tilt or slowly straighten the test tube, and then you will observe a ring in between the layers, upper layer and bottom layer. Bottom layer will have the sulfuric acid, and upper layer will have the iron sulfate and what other nitrate salt solution, that will in the above portion, and sulfuric acid will be in the bottom. So here you can see, you will observe some ring in between the layers. So be careful, do not shake the test tube while you are adding the sulfuric acid or after addition of sulfuric acid. Do not shake, just very gently add the sulfuric acid and then rotate it gently also. Be careful, do not shake at all. Okay, so slowly downside of the test tube, what happens? So what will happen, or what will make the ring? Nitrate you have in your sample, you have added sulfate to iron 2 plus from the iron 2 sulfate. This is iron 2 sulfate, and you have added sulfuric acid from the by dropwise. You have added sulfuric acid dropwise, so that will give you the reaction. The iron 2 plus will convert into iron 3 plus, then rest of the things, and finally this iron 2 plus will react with this nitric oxide NO. This will react with NO to form the ring. This will give you the ring in between the layers. So if you add the sulfuric acid immediately, if you add 2 milliliter of sulfuric acid immediately, that will not give you the ring. So you have to add dropwise, so that you have to give certain time to generate the NO. So in your sample you have iron 2 plus, and you are generating NO, and that NO will react with the sample iron 2 plus and to form the brown ring. This iron NO 2 plus, that will give you the iron ring, brown ring will form where the liquids are meet. So in between the two different liquids, there you will observe some ring. Now let's see how the test is performed. And here, first taking the test tube and taking the salt. Okay, salt is taken. Then here doing some mistake. They have taken the salt. After addition of salt, they have added the water instead of distilled water. They have taken water from the tap water. That is not good way. So in tap water you may have some nitrate. So you should not add water from the tap. So you should always use the distilled water which is free from some ions. So distilled water, that means there is no ions except H plus and OH minus. So you should not add water from the tap. So let's see, still we will observe, because this tap water may not have so too much of nitrate, and our salt definitely we have some nitrate. So we should not add distilled water, we should add distilled water instead of tap water. Okay, now dissolving the sample or the salt into the test tube, this looks clear. Now adding freshly prepared iron 2 sulfate. Freshly prepared iron 2 sulfate. Here you can see this is the freshly prepared iron 2 sulfate, and also almost equal volume. Previously 1 ml and then another 1 ml. Okay, just equal volume. Previously it was 1 ml of nitrate salt solution, that means original solution, and then added another 1 ml. Approximate. You don't need to measure exactly, however approximately you can take equal volume. Okay, then now carefully, now you can see there is nothing, no ring or no precipitation, just it is a clear solution. So after that you have to add concentrated sulfuric acid through the side of the test tube, drop wise. This is the concentrated sulfuric acid. Now okay, see, tilted and adding sulfuric acid drop wise at the side of the test tube. So sulfuric acid is coming here and it will go. Now you can see here some brown color is forming, so need to add little bit more, but I have mentioned we should add 2 milliliter, so that here they have added maybe around 1 milliliter. That is also okay, but 2 milliliter will give you the sample, the ring will be little bit above, because sulfuric acid is 1 ml, so bottom portion is sulfuric acid and above portion is rest of the solution what we have added previously, the original solution and our freshly prepared iron sulfate. So here you can see a ring, brown ring of iron nitrate AgNO 2 plus. This is the brown ring. So you should be careful while you are adding sulfuric acid, that should be added slowly and through the side of the test tube, so that it do not mix up, and also do not shake the test tube. If you shake the test tube, it will be, the ring will be dissolved, so you will not observe the ring. So this is the precaution for making the ring for the nitrate test. And this is the end of my today's class. If you have any question or comment regarding this, then you are welcome to ask.